Have you Googled for the answer?
Yes, ma'am, but not got the satisfactory answer.
What answer was giving?
Ma'am, I have to search it again.
Forgot.
Yes, ma'am. And what to write the derivative of step function?
Derivative of step function, I told you, whenever it is a step function, the Laplace transform of step function is 1 by s. Mathematical
Okay.
representation.
We have to
That
write
one
that,
how to write.
and
Yes,
for
yes.
the integral,
Integral what?
the question is, what does the integral of step function look like?
If you say ramp means the integral of ramp is step. It will be a constant, I think so. Wait, I will check it out. Okay.
Okay, ma'am.
But those things are not necessary for you. This is the topic that comes in control system. They've included all those things in PLAB.
No, ma'am. Post lab one.
Okay, I'll check out
Okay,
and tell.
ma'am.
Okay. I think only 34 people have joined. What about the rest? You people are busy in some or the other way? Okay, we'll begin the class, not waste time. Today, the last topic in the first unit, how to convert delta to star connection and star to delta connection we'll discuss. Already we have studied how the star connection will look like and the delta connection will look like. Now, suppose if in a circuit, if partially if you are having a star form or a delta form, then while reducing the network, you might want to use these formulae. Okay, then simplify it further. That's why some formulae is required for learning out how to convert a delta to an equivalent star and star to an equivalent delta. Okay, this comes for a three-phase circuits already we discussed. Now, let us consider the two circuits that are given here. This one is what connection? First one that is called as what connection?
Star connection.
Star
Delta.
connection or Y connection they call it as. This one is your delta connection
Delta.
they call it as. Suppose if you want to convert the delta to star, okay, if the circuit is given delta form that you want to convert it to a star. The known values are what in this case? They have considered three phases again, A phase, B phase, C phase. Alright. And what are the resistances that are known to you? Given thing
RB
is
and
star, sorry, delta. So for delta, RAB is known to you, RCA is known to you, RBC is known to you. They are given. Okay. And from which you need to know what is RC, what is RA, what is RB. These things are unknown X factor that you want to find it out. Okay, so there is a standard formula that is available. That formula alone you will learn. Okay, in between derivation will not come. Anyway, in between derivation you will derive it by considering any two resistance in series and the other one in shunted manner. That way only they will derive. Okay, now you understood a given thing is delta. Okay, that you want to convert it into an equivalent star. The ring says how to convert a delta to a star. Delta to a star. So delta is like this. A, B, C, they have given three terminals. So this resistance is RAB, this resistance is RBC, this resistance is RCA. Okay, this is known to you that you want to convert into an equivalent star. Okay, so the formula is star is like this. It will be wrong. Star will be like this. Again, A, B, C are the terminals. The markings are RA here, RB here, and RC here. Okay, these resistances you want to find it out. So star delta you want to convert it into star. So the unknown values of RC, RA, RB they are given by certain formulae. Okay, that is listed over here. these formulas, these three set of formulas. So what's the formula for RA? This is RA, no? So what is the formula for finding out RA?
RAB RCA by RAB plus RBC plus RCA.
So similarly, RB is given by the formula RAB RBC divided by RAB RBC RCA. RC is given by the formula RBC RCA divided by RAB plus RBC plus RCA. So in simple terms, if you want to remember this formula, there is an easy way to remember. RA, if you want, means the combination in which you are having a term. So there are three resistances, no, RAB, RBC, RCA. There are three terms here that are known from which you are trying to calculate RA. So if you are to calculate RA, suppose if you are having RAB, there is an RA term there. RCA is also having an A term there. So include these two in the numerator. Okay, leave out RBC term. And in the denominator, you are having sum of all the resistances. That is an easy way to remember equations for star connection. So how will you write RB? Same fashion, if you want to remember it easily, means in the numerator you will be writing whichever terms you are having a B term, B constant there. So RAB, RBC, they have left out what resistance value?
CA.
That does not include B. What is the term that does not include B?
CA.
CA. So CA, they have left it out. As usual, in the denominator, you are having the sum of all the three resistances. If you want to write RC, means again, whichever terms are having C here, C there in their notation, they will be including those terms as a product in the numerator. They have left out what term again?
AB.
AB.
AB. Okay, in the denominator, again, the sum of all the resistance. This is an easy way to remember the formula. If it comes to what conversion?
Delta to star.
Delta to star. Okay, similarly, you need to learn how to convert the other way around. If star terms are given, then how you will be able to get delta? They have given some derivation and all in this final formula. Okay, so let us consider how they have given that star like this. So A,
Ma'am.
B,
Yes,
C,
ma'am.
RA, RB, RC, this is known to you. Okay, so you know the values of RC, you know the values of RA, you know the values of RB. Now we want to convert that into an equivalent delta. Okay, where the unknown parameters are again A, B, C, here you will be having R, RAB, RBC, RCA. So these are X factors. Okay, so you want to know what is RAB, RBC, RCA, because you are converting this to delta. Okay, again there are some set of formula that is given here. So what is the formula for RAB?
A plus RB plus RAB by R.
RAB is equivalent, if you simplify this formula by taking LCM, it will be equivalent to RA-RC divided plus RB-RC plus RA-RB divided by RC. Okay. So any simple method in which you will be able to remember the formula, you tell me. In the numerator, what you are having? In the
Yes.
numerator, you are having the product of two terms of resistance, RA, RB, RB, RC, RC, RA. Okay, that is standard. Only the denominator term will differ. Okay, so in the denominator, here what is the term that is missing? Notation.
RA RB.
It is there, but what is missing? AB is there. What is the missed out term? What is the missed out term?
RC.
A, B, C, na. So what is missing? C term is missing. So that you have to include in the denominator. Okay. Similarly, if you want to write down the formula for RB, then what is the formula for RBC? Same
Ma'am,
way.
R
The numerator won't
RARB.
change. So RARB plus RBRC plus RCRA divided by what will come in the
RA.
denominator?
RA.
RA. Okay. So are you writing down the formula?
Yes, ma'am, a minute.
6 formulae. Okay. Then one more thing, RCA you have to write. So what will be the formula for RCA? Again, numerator will not change. So it will be RARB plus RBRC plus RCRA. And the denominator, what will you have for RCA?
RB, ma'am, RB. By
RB.
RB.
Okay, that's all. Okay, so this formula you remember. In between derivations, they don't ask because it's a complicated one. And complicated problems also they won't ask. Like given in this PPT that I have forwarded, they won't ask complicated problems. Only simple problems they will ask you. But the thing is, you need to remember these 6 formulae. Okay, so this finishes off how to convert delta to star and star to delta conversion. Okay, have you taken on the formula? Formula is very important. For RA, RB, RC in case of delta to star conversion, and RAB, RBC, RCA in case if you want to convert star to delta. Have you taken on the formula, all of you?
Yes, ma'am.
Yes, ma'am.
Shall we go to the next topic?
Yes, ma'am.
The rest also. Have you taken the formula? 6 formula is important. One for conversion of delta to star and star to delta. Another 3 set. Come on, shall we move on? The problems, one or two problems in this part, I will solve it in next class. Okay. Some simple problems, I have to check it out. These are complex problems that is not necessary for you. Only simple problems will come. Okay, I will check out simple problems and I will give it in next class. Okay. Okay. Right. Again, one more time. Finally, just to summarize the formula, if you want to convert delta to star, then what are the formula that you want? RA given by RB given by RC given by. Tell me the formula with that will close this topic.
RA
What is
equal to
RA?
RAB.
RAB.
RCA.
Then, sorry.
Ma'am, RCA, ma'am.
Yeah. RCA then.
RAB plus RBC plus
RA plus RB plus RC.
RC.
Okay. Then next for RB.
RB
RBC.
BC by RAP plus RBC plus RCA plus RBC.
So he decided to do that.
RCA.
And he knew that he
And then RC.
RBC into RCA by RAB plus
RCA
RBC
by
plus RCA.
RCA by RC by C.
Okay, this finishes off first set. Next, if you move on to star to delta means what is RAB?
RARB plus RBRC plus RARC by RB.
RCB
RARB upon RC.
Okay, RBC.
not as a fan because pride. And the easiest way to get in touch with her was to get into showbiz, and he did. Eventually, over the years, he realized that this was actually something that he liked doing, and he stuck to it. It's been 10
somebody's,
years now.
I think
And
they
Amisha Patel
Nandan.
now is
Agarwal.
history in his life. So, like they say, life happens to you when you're busy.
TV is running.
This
The
is a
background.
classic example of that. things don't always work according to plan.
Rival.
So let me tell you something. It's okay to not have hope. I did not have a plan. I had a passion which I decided to pursue, and eventually everything fell into place. You know, when I was
Devkanandan.
my family used to encourage me to sing and dance in front of.
Okay. Okay, ma. So final formula for RCA, RARB, RBRC plus RCRA divided by what is in the denominator? RB. Okay. Okay, so this finishes star to delta. Problems I will solve it in next class, some small problems. Okay, now we will move on to the next unit. With this first unit is over. Next unit is all about AC circuits and the different types of machines that you are having. Already in the first unit we have discussed what is meant by AC and what are the ways in which you can give connection for three-phase AC, all those things. In this unit we will discuss detailed manner about AC. Okay. All right. Now, why do you need to have AC supply? Last class, while discussing in unit 1 itself, I told you. What are the various appliances that you will be working on AC?
All the home appliances work on AC.
All the home appliances, TV,
Refrigerator,
refrigerator, AC,
refrigerator,
everything needs
TV,
this.
AC.
Everything will need a AC supply.
AC.
This AC supply may be a single phase or a three-phase category, and that is having different types of waveforms, basically sinusoidal waveform only. If you refer to these waveforms, all are periodic waveforms only. Why they are called as periodic waveform?
Because after a certain time
If you
they
consider,
repeat themselves.
yes, they repeat. If you consider this waveform means this is representing DC, that is direct current. No matter whatever may be the time, it will always remain constant. Everywhere the magnitude will be remaining constant. That is why it is called as a direct current. Alright. But when it comes to AC, it is called as what current?
Alternating current.
DC means direct current. AC means alternating current. So suppose if this is the instant, the magnitude is maximum. If this is the instant, then the magnitude is negative maximum. If this is the instant, the magnitude is 0. So every time t varies, with variation in t, the magnitude and phase angle also varies. Okay, that is why they become alternating in nature.
Okay, repeat.
Okay, with respect to time, the magnitude as well as phase angle will always keep on varying. That's why these waveforms are all called as alternating waveforms, and there are different alternating waveforms that you are having. Common waveform that you will be using in everyday life is what waveform?
Alternate periodic.
Ma'am, would you please repeat?
There is three sets of waveforms, no? What, ma?
Your
There are
voice was
different types
breaking.
of waveforms.
Sinusoidal.
A sinusoidal waveform is almost used in all cases. Okay, the waveform that you are getting by plugging in into the sockets, this is your single phase AC waveform. Alright. The remaining waveform, there are other sets of waveforms also. What are the various waveforms that represent?
Rectangular and sawtooth.
Rectangular, sawtooth. Apart from rectangular, sawtooth, there are other waveforms also, no? Suppose if you draw a waveform like this, what waveform does it represent?
Triangle.
Triangle.
Triangle. So many different waveforms are there. So these waveforms are called as non-sinusoidal. And this waveform is called as what waveform?
Sinusoidal.
Sinusoidal waveforms. Okay. And as you can see, you have told me that periodic and aperiodic definition. All these waveforms, this is one cycle. Okay, one cycle. Okay, in one cycle, it is showing two different shapes. Okay, this is your positive half cycle and this is your negative half cycle. And again it will turn to positive half cycle and negative half cycle. So every regular interval it is undergoing some change in the magnitude. It becomes negative maximum, it attains positive maximum. That's why they are called as periodic waveforms. And here also it is sawtooth up to this period and again sawtooth and again sawtooth. It will repeat at regular intervals the continuity of the waveform. So that's why they are called as periodic waveforms. Okay. So all these are alternating waveforms. The most popular one is, again I will tell you, sinusoidal waveform. All the other things are non-sinusoidal quantities. Okay, in most of the applications that you are using up in your daily life, you will be always plugging it via single phase sinusoidal AC only. Okay, and if you see to this waveform, this is an AC, as you have already told me. There are three ways in which you can represent any AC quantity. Any AC sinusoidal quantity, there are three ways in which you can represent it. First thing is this quantity. T or theta you will represent here. Theta is equal to omega t. Okay. So that will be taken along this axis. Theta is equal to omega t or t. Now this value is called as what value? This is where the waveform becomes maximum. So this value is called as my Vm. So what is Vm representing? That is my peak value or maximum value. So this is one way of representing AC waveform, peak or maximum value. Alright. Next thing is average value or mean value. That is second way in which you can represent any AC quantity. Third thing is you can use RMS representation also. So there are three ways in which you can represent any AC quantity. So what are the three ways in which you can represent an AC quantity?
Ma'am, RMS value,
Value.
average value, and maximum value.
Yes, RMS or root mean square value, average or mean value, peak or maximum value. So if you have been given with any AC quantity, there are three ways in which you can represent it. One is maximum or peak value they can represent, or average or mean value they can represent, or RMS value they can represent. So you need to know peak value or maximum value. It is easy to visualize. As given in the waveform, you can observe and you can write down what is the maximum value. But you don't know how to derive the equations for mean or average value and root mean square value, but there is a procedural steps that you have to follow for deriving it depending upon what waveform is given to you. Okay. So let us discuss how to derive average and RMS value for given sinusoidal shapes. Okay. You have understood this concept of what is an alternating waveform, what are the various ways in which you can represent an alternating waveform, how you can differentiate different types of waveforms, and what is the meaning of a periodical waveform, sinusoidal waveform and non-sinusoidal waveform. Have you understood? Come on, have you people understood these concepts?
Yes,
What is an alternating
Yes.
waveform?
Yes, sir.
What is an alternating waveform? Direct current means no matter whatever may be the variations in time that you observe, always the magnitude will be constant. That is DC or direct current. But when it comes to alternating current, every time varies
Magnitude will be
instantaneously.
various.
Magnitude as well as phase angle also will vary. Okay, that way those waveforms will be called as an alternating waveforms. And alternating waveforms may be sinusoidal or non-sinusoidal. Sinusoidal is common one that we are using it in your daily residential life for powering the electrical appliances. Other than sinusoidal waveforms, we are also having non-sinusoidal waveforms also. So what are the examples for non-sinusoidal waveforms, sir?
Angular waveform.
triangular waveform,
Triangular
sawtooth
waveform,
waveform,
rectangular.
rectangular waveform, square waveform, all those will come under sinusoidal non-sinusoidal quantities. Next thing is you need to know periodical waveforms. Periodical waveform means as you see from all the graphs, they are having same sort of variation every regular interval. So if it is a periodic variation in amplitude at every regular interval, it will be called as periodic waveform. And there are three ways in which you can represent AC, that is very important. First one is by using a maximum value or by using an average or mean value and RMS value. So they will give you one particular waveform from which they will ask you to derive the formula for mean value and RMS value. That might come in problem. That we'll discuss in today's class. Okay. But before that, you need to know what is cycle, what is frequency and all. So have you studied all these things in your previous classes? What is cycle and what is period? What is time period? Frequency?
Yes, ma'am. Only the not the definitions, but the formulae.
So this is time. Okay, this is time. Time constitutes of one positive cycle and one negative cycle together. That will be called as a time period. And frequency, if you want to write, means that is the reciprocal of the time period. The unit is hertz. Okay, so otherwise it will be called as cycles per second. Okay, cycles per second they will be calling it, or frequency is generally called as hertz. Time period is given in terms of seconds. Okay, all right. One time period for a sinusoidal quantity will be constituting one positive half cycle and one negative half cycle together. They will be forming one time period. All right. And in usual cases, this x-axis parameter, they will be denoted as t, or otherwise they will be denoted as theta is equal to omega t. That is, in angular terms they will write it, while omega is 2 pi of t. All right. So if you want to write it in theta, then theta will be here pi, 2 pi, 3 pi, like that they will write. Okay. If it is pi here, means this will be pi by 2. Like that they will be representing x-axis. If you want representing in terms of theta, both are valid only. All right. So let us move on to derivation of RMS quantities and average quantities. Now, generally, if I want to represent mathematically any sinusoidal quantity, then what is the expression?
Ma'am, A is equal to
This
A
figure
naught
is
sin omega t
sinusoidal.
plus
Yes, this can be voltage or it can be a current quantity. Okay, it can be voltage quantity, or it can be a current quantity, or it can be a power quantity. All are sinusoidally varying only. So if you want to represent voltage, okay, then V of t is equal to, what is the maximum value representation? This maximum value is Vm. So Vm into sine omega t plus phi or theta. Anyway, you can represent theta or phi. Alright. So this is representing my maximum value or peak value. And what is omega t? Just now I told you, either you can represent this as t or theta. Not amplitude. Vm is the amplitude. Okay, omega t is this representation. Now you are learning how to express a sinusoidal quantity mathematically.
Okay.
And you want to derive RMS and average value after that. Okay. Alright. So this is the phase angle. Then there is some particular phase difference between these two. This is phase difference phi, that is represented by phi. Okay. Alright. So this is how you will be mathematically representing any sinusoidal quantity. Again I am telling you, this is your sinusoidal quantity that you are having. Okay, it can be voltage or it can be current, anything. It can be a voltage parameter or it can be a current parameter. Along the y-axis, if you consider this t-axis, this is generally written as t, but here they will write it as general as theta is equal to omega t. Okay, theta is equal to omega t, where theta is equal to 2 pi f t. This 2 pi f is denoted as omega. Angular frequency they call it as. Okay. So theta is angle. So if you are using theta for representing the x-axis parameter, here you will be having pi, here you will be having 2 pi, and it will go on. Okay, so this is how you will be representing generally the x-axis. And sometimes if you are having another waveform like this, then there are some phase difference occurring between these two. That phase difference is indicated by this phi. Okay, understood how to represent sinusoidal quantity mathematically? So if you want to represent the voltage parameter, means V of t will be equivalent to Vm into sine omega t plus phi. Okay. If phase angle is 0, then phi will be equivalent to 0. So simple expression will be V of t is equal to Vm sine omega t. Okay, if you are representing I here in the y-axis, then I of t will be equivalent to Im into sine omega t. So this is the general mathematical representation for expressing any sinusoidal quantity. So what is the expression?
Yeah, t.
What is the expression? Mathematical expression for representing any sinusoidal quantity is what?
A of t equal to a naught plus sin omega t.
V means Vm sin omega t. I means Im sin omega t. That's all. Phase angle is there means plus phi you will be indicating. That's all. Simple terms. Okay. Any sinusoidal quantity, it will be obeying sinusoidal principle. So because of which this will be the equation that you will be getting. Okay. And theta is given by omega t. And this way it will be pi here, 2 pi here, and so on. Okay. Now we understood what is maximum value. Next thing is, suppose if this is the equation, then how to derive RMS and average value for the sinusoidal quantity we need to discuss. So first thing, let us discuss average value. So what is the formula for average they have given? Average is also called as mean value. So what is the formula for average value? What is the formula for average value that is indicated in the slide?
Area under one complete cycle by period.
Area under one complete cycle by period. Okay, so this is the waveform for which you are going to derive. Alright. So mean value you are going to derive for it. So what is the formula? What is one cycle completely? This is one cycle. This is one cycle. So the area under this one cycle you are going to derive. Okay, and then you are going to derive that by the period. So period is pi 2 pi. So you will calculate the area under one complete cycle and divide it by the period. You will be getting the mean value or average value. Okay. So this waveform you are going to consider a sinusoidal quantity for which you are going to derive the mean value now. Maximum value, you know what is a maximum value? As always, this is your maximum value Xm in general, or Im or Vm if it is a voltage or the current quantity. So this is one way of representing any AC quantity. Next things is how to use a mean value, how to use an RMS value. Okay. For different type of waveforms it will vary. So you need to derive that. But remember the formula. What is the formula for deriving average value?
Area under one complete cycle by period.
Area under one complete cycle divided by period. Okay. And root mean square, what is the formula? You can represent maximum value, average value, or root mean square value. So we have learned what is maximum, we have learned out the formula for average. So what is the formula for RMS value? What is the formula for RMS value? Again, it is represented on the slide, no?
Under root area and
Square root of area under squared curve for one cycle divided by period. Okay, and form factor and peak factor, what are the formulae? Make a note of all these four formula. Okay, this will be an important problem section. Okay, with this formula only you will be able to derive the answers. So what is the formula for form factor? What is the formula for peak factor? What is the formula for form factor?
RMS value by average value.
RMS value by average value. What is the formula for peak factor?
Peak value by RMS value.
Peak value by RMS value. Make a note of all these formulae. Four formulae. One is for average value, one is for RMS value, one is for form factor, one is for peak factor that you should never forget. They will give you one problem, sinusoidal quantity or any other quantity they will give, for which they will ask you to determine what is the average value, what is the RMS value, what is the form factor, what is the peak factor, they will ask you to determine. So that time these formulae you have to remember. So what is the formula for form factor again? RMS divided by average.
Value.
Peak factor.
Peak value by
factor
RMS.
is given by peak value RMS. So alright, now we will derive the RMS average value for a given quantity. This is the quantity that you are having. Let us represent it as I now. Same way you can do it for V also. Both will be same only. In the x-axis I will be having theta as usual. So for this waveform, this is your given waveform for which you have to determine the average and RMS value. Okay. Now one more thing you need to know. This is pi, 2 pi, 3 pi, then it will go on. Okay. So this is the given waveform. I want to determine average value. So you know the formula for average value, for which the formula is area under one complete cycle divided by period. So what is one period now for this? One period is 2 pi. Okay. But you are determining mean value. So mean value means if you are summing, this is of positive nature or negative nature, this part?
Positive, ma'am.
Positive. Okay, this one?
What, ma'am? Negative, ma'am.
Negative. So one positive, one negative. If you are taking mean means the magnitude is reversing. Okay, so both will cancel out each other. So what will be the average in general?
0.
Yes, one positive cycle, one negative half cycle, both will be cancelling out each other because they are equal in magnitude but in opposite direction. So they will cancel out each other, and if you derive it in normal way, the answer will be 0. Okay, so you want to go for normal way of derivation. You will now calculate the average only for half time period. So what is your half time period now?
Pi, ma'am, pi.
Now there is a formula. First thing is that you have to write the mathematical expression for this current quantity. So you know how to write current or voltage. If it is varying sinusoidal, how to write it mathematically. So what's the expression?
V of t equal to Vm sin
V
theta.
of t is equal to Vm sin
theta.
So we have written the expression V of t is equal to Vm sin theta. Now I want to derive the area. So area is given by what formula generally? Integral of 0 to, what is the time period that you are considering now?
Pi, ma'am.
Pi only half period you are considering. And what is the V of t quantity you have to write, and you have to integrate it with respect to t theta. So 0 to pi, how to write V of t you know, that is Vm into sin theta into d theta. Okay. So Vm is a constant quantity, so that you can take it out from the equation. So if you are taking it out, then what will happen? Vm you have taken out. Now how to differentiate sin theta term?
Ma'am, we'll get 2 Vm sin theta.
Okay, don't tell the final answer. In between derivations, I am there and you are telling final answer.
Sorry,
Somil.
ma'am. 2 VM, not sin theta. 2 VM only.
Say first, say what will be the answer if I am differentiating sin theta. I am
Minus
sorry,
cos
integrating sin theta.
minus cos theta.
Yes, minus cos theta. Then what are the limits? Pi 0. Okay. Area Vm minus cos theta. The limits that you are going to apply is 0, pi. So if you are doing that, this will be minus cos pi plus cos 0. So what's the answer that you are getting? What is cos pi? What is cos 0? Cos 0 is 1. Yes. This will be 1 minus of minus 1. So this, if you are calculating, means it will be equivalent to 2 Vm. Okay. So this is an area under one complete cycle. But I want the average value. So average value is given by what formula?
Divided by time period.
Divided by time period. Shall rub it? Have you taken on the derivation? This derivation is important. They will give in problem, derive the RMS, average, form factor, peak factor for a given sinusoidal quantity, full wave rectified or half wave rectified. They will ask one compulsory question. So are you taking the derivation?
Yes, ma'am. Yes, ma'am.
Shall I rub it? Rub it
Yes,
now?
ma'am.
Okay. So now I want average value. Average value is given by area under one complete cycle divided by period. Just now we have derived area is 2 Vm. Period is half period. So this will be the I average for what? So V average for
VM by
what?
pi.
2 Vm by pi.
It will come out to 0.6.
Okay, so general answer for a sinusoidal quantity is what? Average value is given by
2 VM by
2 Vm by pi. Okay, if it is IAV means what will be the formula?
2 Im by pi.
2 Im by pi.
If you are deriving IAV means the formula will be 2 Im by pi. Okay? Notations only will change, but the final formula will be always the same if you are having this nature of waveform. Understood the derivation for average value?
Yes, ma'am.
Yes, ma'am.
Okay. Next we need to derive one more representation. What is the other representation? We are done with peak. We are done with average. We have to still derive one more formula. What is the formula? There are three ways of representing AC quantity. Now what are the three ways? Peak, average and one more?
RMS.
RMS.
What is the other quantity?
Ma'am, for complete one cycle average is 0, ma'am.
Yes, given waveform it depends, but for this waveform one is positive half cycle, one is negative half cycle. So the
Yes,
magnitude is quite opposite, no. It may
Okay, ma'am.
vary for a square waveform or a sawtooth waveform. Sawtooth waveform and all, what will happen? If you are taking the average, in that case you have to take
Both
full
are
time
positive,
period.
ma'am. Yes, ma'am. Yes, ma'am.
Understood, huh?
Yes, ma'am.
Suppose if you are having a sawtooth waveform, then for this case, here also it's positive, here also it's positive. So if you are taking average means you have to consider the full time period. Okay, but
Okay,
here
ma'am.
the waveform is sinusoidal. Here it is positive, here it is negative. So it will get cancelled. So in order to avoid that cancellation, they are considering only half time period. Okay.
Okay, ma'am.
Okay, now I want to derive the RMS value. So what will be the RMS? RMS derivation I want to proceed. So you know the formula that you have taken down. Area under one squared curve of cycle divided by same way period.
Period.
This is giving you RMS value. So here also the period is pi, but you don't know area under squared curve of the curve. So what you will do is, again, you know that I is equal to Im sin theta. Now I want IRMS. Okay. So in order to do that, I want area under squared curve. That will be given by square root of, again, 0 to pi. Okay. Then what is I value? I into d theta. Squared curve. So I squared into d theta, square root I have to take. So this is how I will be deriving root mean square. Okay. Square I have to take, then square root I have to take. Okay. So now as usual procedure I have to determine. So what will be the value? Square root 0 to pi
Int
Im squared sin squared theta d theta. Again as usual procedure I have to solve. So Im will be coming out. So inside the bracket 0 to pi, how can I represent sin squared theta? Trigonometry you have studied, no? Sin squared theta is equal to what?
1
1
minus
minus
cos square
cos
theta.
square theta.
1 minus cos 2
Square
theta by 2.
Theta. Yes, ma'am.
Okay,
Yes, ma'am.
so
This is
this 2 also you can take it out. Then you can as usual integrate. Then tell me what will be the answer.
ma'am. 4 should come out.
Shall rub it. All of you understood the procedure?
Yes, ma'am.
Now I am trying to do RMS derivation. RMS derivation means that area I have to square and I have to take square root. Okay, that's all. So the original I have squared and I have taken square root. Then I know that this is equivalent to Im sin theta. So just I am substituting it. Im I am taking it out. Then sin squared theta I can write it as 1 minus cos 2 theta divided by 2. That's all. Okay, that way I have to derive. I will clear the page. Now, what's the answer for that? Tell me. Same way they have did it. So Im divided by square root of 2 you will have. Okay.
4.
Then 0 to pi 1 into d theta minus 0 to pi cos 2 theta d theta. Okay, so what will you have? If you integrate this, it will be becoming theta. Alright, for which if you are applying the limits, it will be Im squared pi minus 0. Okay, then for the second term, it will be sin 2 theta by 2. So what's the final answer that you are getting? You know that sin 0 is 0. So what is sin 2 pi? What is sin 2 pi?
0.
0.
0. Okay. So if you are using the final answer, what is the final answer that you are getting? You are getting pi Im divided by square root of 2 .
Yes, ma'am. Yes, ma'am.
That you have to divide that by entire period that you are considering. So what is the period again? This is IRMS finally. Period is pi. Okay, so what will happen? If
Root
you
2.
solve this, the second term will give you 0. And here you will be having pi pi, I think so. So pi pi will get cancelled. So what is RMS value finally you are getting?
Im by
Im by
root 2.
root 2.
Im divided by square root of 2. So this is how we will be deriving IRMS. Suppose if you want to write VRMS, then what is the formula?
By root 2.
Vm by
Vm by root.
Vm by root, square root of 2. Okay, so two formulae have determined. What is the formula for average you know, what is the formula for RMS you know. Now you can easily calculate what is the form factor and peak factor. Okay, so tell me what's the
Yes, ma'am.
answer. What is the formula for form factor now? Form factor is
RMS
equal to
RMS
VRMS
value by
divided by V average. So you have determined what is VRMS, that is Vm divided by square root of 2 divided by average is what? 2 Vm by pi. So what is the answer that you are getting? Vm will get cancelled. So 1 by square root of 2 into pi divided by 2 you are getting, huh? So what's the answer that you are getting? Use your calculator. Pi is 3.14 square root of 2 to what is the answer?
pi value 1.414.
Pi is 3.14 now.
Yes, ma'am.
What is the final answer? Are you getting 1.11? All are getting.
1.10 something.
Similarly, you do the derivation for peak
Yes,
factor.
ma'am.
What is the formula for peak factor? Peak factor is given by peak value divided by RMS. So Vm divided by RMS value is what? Vm divided by square root of 2. Vm will get cancelled. So what's the answer? Square root of 2. So what is square root of 2 equivalent to?
1.414.
1.414. So this is how you have derived. What are the four values you have derived?
Peak value, average, maximum value, average value, RMS value, form factor, peak factor.
And peak factor. Okay, final summary. Okay, final summary I will give you. Suppose if this is the waveform that you have been given, which may be V or I, theta is equal to omega t, then tell me what are the four values that you have derived. What is your V average, what is your VRMS, and what is your form factor, and what is your peak factor?
V average is 2 Vm by pi.
2 Vm by pi. VRMS is Vm divided by square root of 2. Form factor is 1.11.
1.1.
Peak factor is 1.41.
1.414.
Okay, this might be asked in MCQ or they may ask you to derive the formula and the answers. Okay.
Okay, ma'am.
Alright. Okay. Next case. Say, have you taken out the formula? Shall I rub?
Yes, ma'am.
Okay.
Excuse me, ma'am.
Yes.
Ma'am, what do you mean by form factor?
Form factor is the ratio between RMS to average value.
Okay, ma'am.
You want me to show? Form factor is ratio between RMS to average value. Understood? Vijush.
Yes, ma'am.
So basically, it's always a constant.
What, ma?
So form factor is a constant, right?
It will vary depending upon different waveforms. Okay, how to substitute the RMS given formula, whatever you have got, that you have to substitute. It will vary from waveform to waveform. Okay. So this finishes off this waveform. Suppose in the same way, if you have been given a waveform like this, maybe V and I here, maybe theta is equal to omega t. Then tell me what will be the answer that you will be getting. Here as usual, pi, 2 pi, 3 pi. So again, you have to proceed in the same fashion. You have to determine what is your average. You need to determine what is RMS, and you need to determine what is the form factor and peak factor. Tell me what will be the answer. How will you do derivation? What is the formula for average again? I average is equal to area under one complete cycle divided by period. Okay. Period here is you will consider pi or 2 pi.
Pi, ma'am.
Why pi? No. No pi. Okay. Here you are having some answer, but here it is 0. Okay. So you have to consider 2 pi. Okay. Alright. So you have to split up the equation accordingly. Suppose if I am writing area under this is equivalent to, you have to split it into two sections. From 0 to pi, the answer is Im into sine theta d theta. Then plus from pi to 2 pi, what is the value? Pi to 2 pi, what is the value of I?
Im sine theta plus.
No. Is there any variation here from pi to 2 pi?
Oh, ma'am.
Then in that place you have to give 0. Okay, d theta divided by again entire time period 2 pi you have to give. Like that you have to derive. Okay. So tell me what are the answers that you are getting. I will pick out somebody and I will ask for answer. So all of you derive it. This is an 8-mark question. Vishesh, will you give me the answer?
Ma'am, I'm still trying.
Mita? Mita Yashwant?
Ma'am, I am by pi, ma'am.
What about Mita Yashwant? You got I am by pi, yeah?
Me too, ma'am. I am by pi.
What about the rest in class?
I am by pi.
Yes, ma'am, I got, ma'am. I
I am by pi.
How many of you got I am by pi?
I am by
How
pi.
many of you got I am by pi? I am by pi is correct only. So how many of you got it?
I got, ma'am.
I also, ma'am.
Ma'am, I got,
also.
ma'am.
Okay, let's check the answer. I'll go to the other way. Same way you people continue to derive RMS also. Same, but you have to square and square root, that's all. Find RMS also. And form factor and peak factor. Im by pi is correct. Similarly, you will derivation for RMS. I am hoping all understood the concept. Okay. So this was the waveform that I was talking about, for which the answer you have told me is Im by pi. Let me check it whether it is correct or not. Yeah, it is. From this part, 2 will get cancelled. Im by pi is the answer. Okay, so you are correct. Similarly, you determine RMS also.
Ma'am, RMS value Im by 2 root 2, ma'am.
Yes, RMS is Im divided by 2.
2 root 2, ma'am.
No 2 root 2. 2 will come. Check it out. Im by 2 is the answer for RMS. Period is 2 pi, you remember.
Ma'am, I am by 2.
Yes. What about the rest? Have you got Im by 2 for RMS?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Rest also have you got Im by 2, all of you? Linson, Neeraj.
Still doing.
For average it will be Im divided by pi. For RMS it will be Im divided by 2. Veeravardhan, you got it right?
Yes,
You
ma'am.
must have did some mistake.
Yes, ma'am. Yes, ma'am.
Sivanesh.
Yes, ma'am, I got now. Im by 2.
So similarly you would derive for form factor and peak factor and tell me the answer. Form factor is RMS divided by average. So the answer is IRMS is Im divided by 2 divided by average is Im divided by pi. So Im will get cancelled. So the answer will be pi by 2. So what is pi by 2?
1.57.
1.57. Let me check. They have not calculated that, I think so. Okay, all got pi by 2, but
Yes, ma'am. Yes, ma'am.
peak factor Vm divided by Vrms. So for Im. So Im divided by IRMS is what?
0.5.
Im divided by 2. So Im will get cancelled again. So what's the answer?
2, ma'am.
2.
Okay. So this is form factor. Okay, so this will be the answer. Suppose if you are giving what, if you have been given with what nature of waveform?
Positive.
This is what waveform? This is half wave rectified waveform or full wave rectified waveform? You know what is a rectifier. So what is rectifier?
Ma'am, half wave rectifier.
What is a rectifier? You tell me first.
And which modulates the direction?
This is half wave rectified waveform. Okay. Sometimes in question they will not give you the type of waveform. They will simply determine, you will ask you to determine the values for a half wave rectified waveform. That time you have to draw this waveform and then you have to proceed. Okay. Understood?
Yes,
okay,
ma'am.
suppose if you are being asked to determine the same for a full wave rectified waveform, then full wave rectified waveform means
The sinusoidal one.
Just substitute with 2 pi.
0 to 2 pi, ma'am.
you have to draw the
Negative and
graph. This
positive.
is full wave rectified.
And second is also positive.
The second is also positive. Okay, so you have to use full time period only. So tell me what will be the answers for them also. Your data. This is for a full wave rectified waveform. So tell me what is RMS, average, form factor, peak factor for that also. Here also you can use half time period, but you have to do it twice. What is the answer that you are getting for average? Do it. I'll just write out the formula alone.
Zero. Average value.
It will not be 0. Both are positive. If you are doing it for 1 cycle, you multiply by 2. That's all. So
Yes, ma'am.
average RMS is
Ma'am, it is coming at 0.63 IM.
like that. Okay, these are the formula for I average and RMS. I think formula is correct only. The answer is, I have to check. The 4 IM by 2 pi. So what's the final answer? 4 IM by 2 pi means? So this is how we have to derive I average and I RMS. So the answers that you got for average is what? 2 IM by pi. All got 2 IM by pi for average.
Yeah.
Yes, ma'am.
Yes, ma'am.
Similarly, do the same for RMS also. All are doing the derivation for RMS. Ritesh, Priyam, Om. Tejaswani, all are doing the derivation for RMS.
Yes, ma'am.
Dhanush,
Ma'am, IM by 2 root 2, ma'am.
what about the rest I have called Priyam, Om?
No, ma'am. IM by
All
root
were IM
2,
by
ma'am.
what?
IM by root 2, ma'am. IM by root 2.
IM by square root of 2 is correct, but what about the rest? Rajashi got IM by square root of 2. Randeep,
Yes, ma'am.
I am by 2.
so shall we proceed for form factor and peak factor?
Yes, ma'am.
Yes, ma'am.
Yes, RMS is IM squared divided by square root of 2. So using this to determine what is form factor and peak factor and tell me. I think same values that you have got for the first waveform that you have discussed, 1.11 and 1.214 you will get.
Yes, ma'am.
Ayappa and Lakshman doing or what? Ram, Charan and Lakshman.
Ma'am.
Yes, ma'am. Yes, ma'am.
All got what answer for form factor and peak factor now? Form factor is equal to IRMS divided
by
by
average.
average. The answer will be
1.11.
1.11. Then similarly, peak factor.
1.414.
Peak factor is VM IM divided by IRMS. So the answer will be 1.414. Okay, same as the first waveform. Alright. But the derivation part alone will differ little bit. Okay. So these are the three waveforms for which they will ask you to derive average, RMS, form factor and peak factor. There are ways to derive the same parameters for other waveforms also, but usually we have decided not to give those waveforms. So in case if it is to be asked, cover the part of syllabus means I will discuss. Okay. Now have you people understood everything?
Yes,
So
ma'am.
finally, tell me what are the
Yes,
three
ma'am.
ways in which you can represent any AC quantity. How will you be able to represent? Any AC quantity if it is given means you can represent it in terms of peak value, you can represent it in terms of RMS value, average value. So how to derive these values plus the formula for deriving form factor, peak factor is important. Problems will come from this section. Okay. Alright. And some standard ways of definition of RMS and average you have to discuss. Suppose if you are having an AC circuit means the same amount of DC that is passed to produce the same amount of heat, they will give some formula. Formula I will try to state it in next class. Okay, in this PPT it is not there. Alright, definitions are also important. Okay. One small formula they have given here. Read the problem. A conductor carries simultaneously a direct current of 10 ampere and a sinusoidal alternating current with the peak value of 10 ampere. Find the RMS value of the conductor current they have given. Okay. So in the equation form, if you are writing means this is a DC current that is carried, that is 10 ampere. Okay. 10 ampere DC it is carrying. This is your AC part. Again 10 ampere. Alternating current. Peak value is 10. This is your IM. Alright. So AC plus DC it is carrying the conductor, and they have asked you to find out the RMS value for it. Okay. So for DC the RMS value is 10 itself, but for AC what is the RMS value? It is an alternating current that they have given, so like this only. So what is the RMS value that you have determined?
IM by root 2.
IM by root 2, ma'am.
IM divided by square root of 2. So what is IM value that is given? 10 divided by square root of
10,
2. So
ma'am.
what's the answer? This is for AC.
10 into
7.09.
RMS. 7.09 that they have substituted here. So then they have taken sum. Okay. Alright. This is for AC. This is for DC. And this is for AC. And they have taken square root and they have found out the answer. Alright. This is one simple problem. Understood this problem or not?
Yes, ma'am.
Again, I'm telling you, it is stated in the problem that a conductor is carrying two components. One is a direct current of 10 ampere for which the RMS will be 10 only. And AC component, peak value, they have given it as 10. So if you want to express
IM
it, the
by root
expression
2.
will be, this is IM. So divided by root 2, if you are doing means IRMS for that AC. Okay. Then finally, you have to consider DC as well as AC for calculating total RMS. The total RMS is given by this formula, that is IRMS DC squared plus IRMS AC squared. That they have derived 12.27247. Okay. All understood this problem?
Yes, ma'am.
Yes, ma'am.
Okay. This concept being done, let us next discuss what are the different types of power and what is the power triangle you have to discuss. So the three types of power is, first one is, what is the name of this power?
Active power.
Active power, real power or active power or true power, generally denoted as P, and the unit is watts. Okay. So what is the first power that you are going to discuss about? Real power or active power or true power is the name. The notation is P and the unit is watts. Okay. Next. Next power is what power?
Reactive power.
Reactive power. Reactive power is given by the notation Q and the unit is VAR. VAR means volt ampere reactive. Okay, volt ampere reactive denoted by Q, that is your reactive component of the power. Okay, and one more power, that is called as your apparent power. Apparent power, for which the notation that you commonly use is S, and the unit here is VA. VA means what?
Volt ampere.
Volt ampere. Now tell me, what are the three types of power that you are having in any system?
Active power, reactive power, apparent power.
All understood the three types of power? What are the three types of power, ma?
Active power, reactive power, apparent power.
Okay, first one is active power, denoted by, what is the term that is used to denote active power?
P.
P.
P. The formula is VI cos theta or cos phi. The unit is watts. Okay, remember the formula also. The next power, what is the next power? Reactive power.
Reactive power.
The representation is Q. The formula will be VI sin phi. And the unit is var. Var means what?
VAR.
Volt ampere
reactive.
Reactive. Okay, and one more power. What is the last power?
Apparent power.
Apparent power.
Denoted by S.
Apparent power denoted by S. Formula is VI. Unit is VA.
VA.
Okay, so there are three types of power. These are the three types. One is active power, or true power, or real power. What is the formula for it?
VI cos theta.
VA cos phi or cos theta? Phi you generally
Cos
represent
theta.
phi. Okay, what is the unit?
Watts.
Watts. Next one is reactive power. What is the formula for reactive power and notation?
Q equal to VI sin phi.
And unit is volt ampere reactive. For apparent power, the formula is S equal to VI. and the unit is volt ampere. Okay. Now, next one more thing. In all these terms, you are having one phi there. Phi. That phi is called as power factor. Okay, power factor. Now I will discuss the power factor and plus power triangle. But you understood the three types of power, huh?
Yes, ma'am.
What are the three types of power for one last time?
Active power, reactive and apparent power.
Okay, so in any AC circuit, active power is the real power consumed by the circuit. That is the power that you usually use up. And what is the formula as I told you? P is equal to VI cos theta, unit is watts. Then reactive power. Suppose if you are having inductive component or capacitive component in the circuit, then they will be called as reactive components. So the power associated with those reactive components will be considerably giving you reactive power. And what is the unit in notation? Q is equal to VI sin theta, and unit is what? Volt ampere reactive. Okay, volt ampere reactive. Alright. Now, apparent power. Apparent power is the sum of these two powers. That is real power and reactive power. The sum of these two power is called as apparent power. And what is the formula and unit? S is equal to VI and the unit is volt
Ampere.
Volt ampere. Okay. Now, what is power triangle you have to discuss. So, there is a triangle that is drawn. It is a right angle triangle. The first parameter that you have to draw is this one. That is representing what power?
Active power.
P represents what power?
Active power. Active power.
Active power. What is the formula for it? VI cos theta. Okay. Now, this is with respect to that resistive component, usually in phase component, that is resistive component. Now, apart from resistance, you may also have L and C component in the circuit. So that will be corresponding to X, that is reactive component. So for which the power associated is Q, that is reactive power. What is the formula for it?
VI sin theta.
VI sin
phi.
So VI sin theta sin phi. Okay, always you have to represent it as a perpendicular component because it is out of phase component. So it will be a perpendicular component. Resistance means in phase because V is equal to IR. So it will be an in-phase component, so you are drawing it vertically. Now, how will you represent S? S, I told you that it is the sum of the two powers P and Q. So if you are taking the sum, this will be S. What is the formula for the apparent power?
VI.
VI. Okay, how you can get VI? Tell me if you are going to sum these two vectorly. So if you are summing these two, it will be V squared, I squared, cos squared phi plus sin squared phi.
Yes, ma'am.
This whole square root. So it will be becoming VI. What is cos squared phi by sin squared phi?
1.
So that is how you got this formula VA. Okay, this triangle is called as what triangle? What is the name of the triangle? This triangle is called as
power triangle.
Okay, sometimes they will ask you to draw this diagram in 4 mark. Okay, so this is what is called as power triangle. Okay, power triangle. Understood what is power triangle?
Yes, sir.
Understood or not?
Yes, ma'am.
Okay, from this only we will derive the term that is power factor. Okay, power factor we will derive. Let us consider what are the 3 sides for any right angle triangle. This is my adjacent side. This is my opposite side. This is my hypotenuse. Okay, so if I want to derive the formula for power factor, it is given by cos theta, you assume, or cos phi, any notation. So what is cos phi? That is power factor. What is cos phi? That is adjacent by hypotenuse.
Adjacent side by hypotenuse.
So what is your adjacent side? That is P. Opposite
ma'am.
side, sorry, hypotenuse is what?
Yes.
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 So what's the formula for P? P is given by VI cos phi
Cos theta.
divided by VI.
VI. VI.
Okay, so this is called as what?
Power factor.
So how will you define power factor? That is the ratio between what two powers?
Ma'am,
Ratio
active
of
power
active power to
or by
apparent
apparent
power.
power.
Okay, here they have given ratio between real power to
Power. Apparent power.
apparent power. So cos phi or cos theta, that is equal to P divided by S. Okay. Alright, this one is phi r. So this triangle is called as power triangle. That's all. Okay, so there are three components of power: real power, reactive power, and apparent power, from which you will be learning how to derive the formula for power factor. Okay, understood?
Yes, ma'am.
Okay, next, in a circuit, okay, you may have R component separately, or you may have an inductive component separately, or you may have a capacitive component separately. All may be connected to an AC supply. Okay, or you may have RL in combination, RC in combination, or RLC in combination. So in case if you are having such a combination, then how the circuit will behave, what will be its voltage, current, and power factor, what is a phasor diagram, that you have to discuss. Okay, these are what are called as single phase AC circuits. Okay, single phase AC circuits, where a sinusoidal nature of supply will be given to a resistance or an inductance or a capacitance individually, or it may be applied across a series combination of RNL or RC or RLC. So in that case, how the circuit will behave, what are the various equations that you will be using up, what are the phasor diagram representations you have to learn. Okay, that is your next concept that we will discuss now. So for your cycle test one unit will be the syllabus, okay. Okay, suppose if you are assuming only one resistance component is connected across a sinusoidal supply. So this is your Vm sin omega t. Here they have given cos omega t. You can derive it by sin omega t also. In book they have used sin omega t. Both are one and the same. They will give you the same answer only. So this is your all component. This is your I of t. This is your voltage across R. All these things you have to derive. Plus what is the formula for this single phase R circuit you have to derive. Okay. And how you can represent the phasor representation you have to learn. So let us assume V of t is a cosine waveform. Okay. Cosine waveform whose mathematical representation is Vm cos theta, or otherwise you can use Vm sin theta itself. Okay, that is easy for you because you are using a sinusoidal representation. So let us consider sin theta itself. Now I want to know what is the current. So what is the formula for current
T
by
by R.
Ohm's law?
T by
V
R.
by R. So I know what is V. V is Vm sin theta divided by R. Okay. Now I will group this Vm divided by R and I will be writing it as Im. So now I have got I of t is equal to Im sin theta. So this is the relationship for I of t and this is the relationship for V of t. Now I want to represent both in terms of a phasor diagram. Okay. So how can I represent the phasor diagram? Here. This is my phasor diagram. So reference I have considered as V. And how can I represent I? V is given by Vm sin theta. I is also given by what? Im sin theta. Both are in phase quantities or out of phase?
In phase, ma'am.
In phase. So both are in phase means the same reference itself I can represent my I also. So this is my phasor diagram for resistor. Now I want to represent power factor. So what's the formula for power factor? Another way of defining power factor is also there, that is cosine of the angle between V and I. So what is the cosine of the angle between V and I for this case, for resistance?
0, ma'am.
0 degree.
Cos 0.
0.
Yes.
0.
This is V, this is I. If I want to represent cosine of the phase angle between V and I, there is no phase angle difference. Both are in phase. So this cosine value will be 0. So cos phi is equal to power factor is equal to 0. Okay, that is why whenever there is a resistance in the circuit, they use UPF term. UPF means what? Sorry. Remember cos 0. Wait, there is one thing that you would remember. Okay, cosine of the phase angle. Phase angle is 0. So what is cos phi?
0.
That is power factor.
1.
So cos 0. So what is that?
0.
1. So this is why whenever there is resistance in the circuit, they will always use the term UPF. So you know what is PF? PF means power factor. What is that U? 1 is represented by unity. Okay, so unity power factor. Only for what case? Resistance or inductance or capacitance? Resistance. Okay, remember this concept. Power factor for a resistive element is equal to what value?
1.
1. So what is UPF?
Unity power factor.
Unity power factor. Okay, this is only for an individual resistive component. But on the other hand, if you are having and power also, you can use V is equal to IR. It's the same that you already know, so I am skipping that part. Now suppose on the other hand, if you are having an inductive component, which is again being given by Vm sin omega t or Vm sin theta. This is an inductive component, I of t, the voltage across EL. Okay, for this circuit, what will be I of t? Same way how to derive. Now you are considering a pure inductive circuit which is connected across an AC supply. AC supply is indicated by Vm sin theta. Now I want to derive I of t. So what's the formula?
Im sin theta.
Okay, I know that V is equal to Vm sin theta. I want to determine I of t. Okay, there is a VA relationship for inductance. What is a VA relationship for inductance? V of t is equal to L into di by dt now.
dt, yes ma'am.
So from this, what is my I of t? 1 by L into integral of V of t into dt. Yes or no? This is how I will be relating voltage and current for what element? What is the element that I am considering? I am done with pure resistive. Now I am considering pure inductive component. Okay. Now I need to substitute V value. Okay, V value is given by Vm sin theta, not t, but it's given as theta. So I will change it to theta here. And in place of V of t, I will be substituting Vm sin theta. So tell me what is I of t?
1 by L into integral of Vm sin theta d theta.
So now I of t will be equivalent to 1 by L into integral of
Vm into
Vm sin theta d theta.
d theta.
So integrate it and tell me, Vm is a constant, so I can take it out. So what is the integration of sin theta?
Minus cos theta.
Minus cos theta. Okay. Alright. Okay. Now how can I represent cos theta in terms of sine?
1
There
minus
is
sine
one.
into theta by 2.
2 under 1 minus cos square theta.
No. What is sin theta plus pi by 2? What is sin theta plus pi by 2?
Cos theta,
Cos theta.
Cos theta.
Oh, so I can use that, no? Minus cos theta or cos theta?
Plus cos
minus
theta.
cos theta. Plus
What is the integration of sin theta?
minus
Minus cos theta only, no?
Minus cos theta.
Okay, so I can write this as Vm by L sin theta plus pi by 2. Yes or no?
Yes, ma'am.
What you people are doing?
Yes, ma'am. Correct, ma'am.
Okay, then suppose if I am equating this theta to omega t, okay, and I am deriving it in a different way, okay, because one more equation, reactance you need to discuss about. So let us consider. What, ma?
But it should
Where
be
are we,
minus
sir?
sine pi by 2 plus theta, na? Because sine pi by 2 plus theta gives plus
I
cos
think it's
theta.
sin theta plus pi by 2 is minus cos theta something. Check it.
No, ma'am. It is positive cos theta.
Yes, ma'am, it's positive.
Ma'am, because
Which
sine
one is
is
positive
positive.
cos theta? Okay, maybe minus what is sin theta minus pi by 2?
Ma'am, positive cos theta.
Cos theta, ma'am.
Cos theta.
Both are positive, huh?
Yes,
Sin theta
ma'am.
plus
Yes, ma'am.
sin theta plus is also positive,
And minus is also positive.
and sin theta minus pi by 2 is also positive, huh?
Yes, ma'am. It
Yes,
should be
ma'am.
minus sign
Okay,
in
I'll
front
check it.
of sign.
Okay, anyway, I will continue in the next class. Now I will check it and tell. Okay, but one more thing you remember. Okay, we'll continue this in next class, I think. So I'll check out the derivation. But in that case, I will be deriving in terms of theta is equal to omega t, because the resistance reactive component for XL is. Do you know what is reactance and what is the formula for
Yes,
inductive
ma'am.
reactance?
Yes, ma'am. Under root
XL
What
R
is
equal
square
to
formula?
plus
1 by
omega
Yes,
square
XL
L
equal to
square.
1 by 1 omega c.
1 by omega L. So that omega term you have left out. So you have to substitute theta is equal to omega t, and then you have to differentiate with respect to dt. Then only you will get
Ma'am,
this term.
inductance is omega
Okay, so I
L
will.
and in capacitance is omega 1 by omega c.
Yes.
Ma'am, it is
Oh, this is
omega L.
omega L.
No.
Yeah.
Omega L.
Okay, omega L. Xc is 1 by omega c, correct? Okay, so you need to bring that final form of equations to be of this form. So still there is one capacitive circuit also to be dealt. Okay, we will continue this in our next class because there is no time. It's already 10:42. I will check up that sin theta plus pi by 2 also at the same time. Okay?
Okay.
Okay. I will continue in the next class, ma. I will only today's class we will discuss pure resistive circuit. In my next class we will discuss pure inductive, pure capacitive, RL in series, RC in series, RLC. Okay.
Yes, ma'am.
Alright. I'll check up the trigonometry formula also. Don't worry. Okay, there should not be a minus sign. Okay, I'll check out how it comes. Alright.
Thank you,
So all can discuss. Okay, ma.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Okay, ma.
Thank you, ma'am.
Thank you, ma'am.
Thank you,
Okay.
ma'am. Thank you, ma'am.
Okay.
Ma'am, would you please
Okay.
share the class video today's?
Yes.
Thank you, ma'am.
Okay, ma.